Hello, I'm Chad Boyd, Rangeland Scientist at the Eastern Oregon Agricultural Research Center. One of the hottest topics in management of western rangelands is that of riparian management. Riparian areas are those habitats that influence and are strongly influenced by adjacent aquatic environments. While it is true that riparian areas often make up only a small percentage of the overall landscape, a look at the figures can be surprising. A 1992 EPA report put the total length of streams and rivers in the lower 48 states at around 3.5 million miles. Oregon had about 90,000 miles. Another report indicated that Oregon had about 15,000 miles of rivers, streams, and intermittent drainages that flow through agricultural lands. Management of these habitats is both cussed and discussed to no end, but less often do we talk about why riparian areas are important. With that in mind, I'd like to spend the rest of this week talking about the ecological functions, as well as the benefits of riparian habitats to not just wildlife species, but also livestock production. If there is anything constant about riparian areas, it's that they change over time. But change is a two-way street. Water can be thought of as energy, and when a stream channel gets too much energy, something has to give. A severe flood event may cause a stream channel to widen and become shallow. Over time, more moderate flood events may cause this same stream channel to narrow as sediment is deposited in the riparian zone and stream banks are built up. This process of renewal is important because a more narrow stream channel will spill more water into the floodplain, inundating a larger area during high flow events. The saturated riparian area then acts as a reservoir for the stream. The more water it holds, the longer the reservoir lasts. When the reservoir runs out, the stream will lose water to the surrounding riparian zone, but until then, these groundwater inputs can help to sustain stream flow. For the last couple of days, we've been talking about important functions of riparian areas. Today, I want to talk about nutrient cycling. Nutrients such as nitrogen can become attached to sediment particles that are washed into the riparian zone during flood events or spring melt-off. Aquatic vegetation cover within the riparian zone will act as a filter to decrease the amount of nutrients entering the stream. In riparian systems with good channel structure, overbank flooding will disperse nutrients that do enter the stream throughout the riparian area, where they may be filtered out of the moving water. This filtering of nutrients not only acts to decrease the nutrient load in the stream, but effectively spreads out these nutrients within the flooded riparian zone, increasing the supply of nutrients for riparian plants. These plants take up the nutrients, utilize them for growth and maintenance, and then return them to the soil in the form of dead plant material. In systems with poor channel structure, floodwaters may be largely confined within the channel, eliminating this filtering process and decreasing nutrient availability for riparian plants. For the last couple of days, we've been talking about some of the important ecological functions of riparian areas. Today, I want to switch gears a bit and talk about the importance of riparian areas for wildlife. Beyond their obvious importance to fish and other aquatic life, riparian zones are used by a wide diversity of terrestrial wildlife. One report suggested that 60% of migrant songbirds use riparian habitat in the western states as stopover areas during migration or for breeding habitat. Another report estimates that 75% of terrestrial wildlife species in southeast Oregon are dependent on riparian areas for at least a part of their life cycle. Riparian areas can provide standing water, dead trees for cavity nesting birds, shade, and travel corridors between other habitat types. They also contain a high diversity of plants for forage, from woody plants to forbs and grass species. Because of high water availability, these areas can provide forage after other habitats have dried up. For example, sage grouse often take their broods to riparian areas following desiccation of surrounding sagebrush communities. Good management of riparian areas not only benefits the health of the land and its wildlife inhabitants, but it's also good livestock management. We recently completed a study that looked at forage production on 3 small streams in Harney County. Over a 3-year period, forage production averaged just over 3,000 pounds per acre. But let's put that into perspective. If you have a good conditioned small stream flowing through a pasture for 1 mile, and that stream is about 4 feet wide, with a surrounding riparian area that averages 35 feet across, then you're looking at just shy of 4 acres of high-producing riparian habitat per mile. Put another way, this small stream could produce around 6 tons of forage per mile of stream. If this were a moderate elevation stream, flowing through big sagebrush habitat, the riparian area produces around 4 times the amount of forage per acre as compared to the surrounding sagebrush habitat. However, if poor grazing management leads to deterioration of the stream, a drop in the riparian water table, and encroachment of sagebrush into the riparian zone, then that production gain goes away. Good grazing management not only improves the quality of the riparian resource, it can also increase your bottom line. I'm Chad Boyd, and thanks for listening.